Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In the past 2 days, we were talking about area of different shapes and surface areas, either lateral or surface area of 3D shapes. In fact, I think I failed to mention, the surface area of a sphere. So we can write this right now. And then today, as I mentioned, I'm going to go over the volumes. So before I start with the volumes, as I said, if we have a sphere, okay, so let's draw a circle here and we say we have a sphere. The surface area of a sphere with radius r is 4 pi r squared. So we know a circle has an area of pi r square, and the surface area of the sphere is 4 times that. Okay. Um, Today we are going to talk about the volume, and as an introduction, like I mentioned when we started the area, and I told you what did we call a 1 square unit, right? So if you have a square with size a unit, meaning 1 centimeter, 1 mile, 1 inch, it doesn't matter. And then we say, okay, so the area of a shape is basically we are trying to cover it with these tiny bits that we call unit square. So how many units, right? How many units square? We are going to do something similar with the volume. So for example, if I draw a cube and this cube has a size of 1, like maybe it's not drawn perfectly to scale. And again, like I mentioned yesterday, if we have something like a die that we play with, or we have, like I mentioned, also the Rubik's Cube, right? So if I assume I have that cube and it has the dimensions, of course, we call them length and width, even though they are the same, a length, width, and height, and each one of them is 1 unit. We call that 1 cubic unit. So if this unit was a centimeter, so that's 1 cubic centimeter. For example, 1, we write it centimeter cube, and we call it cubic centimeter, or 1 cubic inch, or anything with a 3 on the top to tell you that there are 3 dimensions. I multiply 1 centimeter by 1 centimeter by 1 centimeter. So 1 times 1 times 1 is 1. And centimeter times centimeter is centimeter squared, times centimeter again is centimeter cube. Now, if I have a shape, like be it, say, a sphere or a cube or a pyramid, we are saying how many of these cube can like fill the space inside this shape. So if we take a large square, so let's say I have, a large cube, and let's say I have a cube that looks like that. Maybe I took, this is like 1.5 of these. So maybe we extend it so we make it, okay. And then so let's say this is a cube, and Sorry, I will go over what we wrote. Okay, so we have a cube, and let's say the side, each side is 4 centimeters. You see that since these are 4 centimeters, if I have a cube where each side is 1 centimeter, I can fit 4 of them here, right? And 4 of them there. So the bottom area, like the bottom face, will be covered by 16 such cubes, right? 4 here, and 4 and 4 and 4. But that's only one layer that has a height of 1. So if I place another 16 and another 16 and another 16, I will get 4 times 4. So volume equals 4 times 4 times 4, or 64 cubic centimeter. And that's why we say 4 cube is 64. That's the meaning of it. Say, nice. Okay, so like if I have a straight line and it has a length of 4, and I ask you what's the length, you say 4 centimeters. Why? Because the unit of length is 1 centimeter, and I put 4 of them next to each other. When I have a square, I say, oh, I have to have 4 on this side and 4 on the normal side, the perpendicular side. So it would be 4 times 4. That's why we say 4 square means 4 times 4. 4 cube is 4 times 4 times 4, because I have 4 on this side, 4 on that side, and 4 on the height. So altogether, they have to be 64. Remember when we said, if I have a line of, say, size L, and I move it parallel to itself such that this L doesn't change, it stays L. Whether I move upward or on a slant line, it doesn't matter. Eventually, the area would be this L times the height, if the length doesn't change, or if this L doesn't change. So if that's A, I say that becomes a rectangle, and I say, oh, it stayed L all the way for a distance of A, so the area would be L times A, correct? Even if I make it a parallelogram, so it doesn't have to be perpendicular, it can be slanted, okay? Slanted like that, but the height is still A, so the area of this parallelogram is also L times A. Here it's the same idea. The area of the base is 4 times 4, or 16. If I move the same area parallel to itself, either upward, perpendicular, or inclined, but in such a way that every time I take a slice and I measure the area, it is still 4 times 4, so it's 16. In which case, okay, I would multiply this area, which is 4 times 4, by the height. In this case, it's also 4 because that's a cube. But if it's a rectangular prism, okay, so I have a rectangular prism that looks like that. And let's say this is 5, this is 5, and this is, let's say, 9. And I ask you, what is the volume? You say the volume of, first of all, area of the base equals 5 times 5 equals 25 square units. And it's 5 times 5 here, 5 times 5 here, times what? Times 5 there. So the volume of that rectangular prism would be 5 times 5, that's the area of the base, times 9, which is the height, and you get 225 cubic units. Okay, so it's so easy to find the volume of either a cube or a rectangular prism, or even a triangular prism. Let's say, okay, here's a triangle. And again, let's say this is perpendicular, and let's make it 6, 8, 10. I don't care about the 10, by the way, but just applying Pythagoras, the Pythagorean theorem, it would be, and let's say the height is 50, or even it looks like much larger, so let's make it 25. If I ask you what is the volume of that triangular prism, you say, oh, it's the same area. It didn't change all the way. So all what I have to do is to find the area of the base, which is 1/2 base times height. I can consider either one as base and the other is height. And since it doesn't change for a distance of 25, I multiply that by 25. 324, so that would be 600 cubic units. Okay, so now we know how to find the volume of a cube, the volume of a rectangular prism or a triangular prism or any kind of prism if I know the area of the base. I just multiply it by the height. So that leaves us with a cylinder. That leaves us with a cone, also a pyramid, and finally a sphere. So let's see those. I printed a page from a website, and it has all these shapes. So let's write down the volume of the shapes. So I have a cone. Volume of a cone is 1/3, not 1/2, 1/3 area of base, which is a circle, by the way, area of base times the height. Remember, when we were considering the surface area or the lateral area of a cone, we said it's half the circumference of the base, which is pi r, not 2 pi r, just pi r. And then we multiplied by the slanted height. The slant height, L, if we call it L, the surface, the lateral area of a cone would be 1/2 the perimeter, which is 2 pi r. So 1/2 of pi r is just pi r times L. But here for the volume, it's 1/3 the area of the base, which is pi r squared times the height. So it's 1/3 pi r squared times h. We know this. We know this. We know that we don't have a pyramid, but I will show you the pyramid. The volume of a pyramid is very similar. Volume of a pyramid. The pyramid may be like with the triangular base. We call that a tetrahedron, meaning a shape with 4 heads, because no matter where you turn it, it stays the same. It will have 3, like a triangular base and an apex. So the area of the pyramid equals also 1/3 area of base. Notice the base is a triangle. So base times height over 2, area of base times height. So exactly like the cone. The only difference, of course, is that the cone has a circular base. The pyramid may have a triangular base or a square or a rectangular base. So you find the area of the triangle or the square or the rectangle, and then you multiply it by the height. Finally, the only thing we haven't covered yet would be the volume of a sphere. Remember, we said the surface area of a sphere is 4 pi r squared. Now, the volume of a sphere is 4/3 pi r cubed. And that's really all. So let's apply this to these 9 figures. Unfortunately, I didn't notice there was no pyramids, but maybe I just told you how to do it. Very similar to that. It's the same concept. We say the volume is 1/3 area of base, which is pi r square times h. Now, we can use the calculator. Okay, so here's the calculator. The area of the base is pi r square, right? R here is 7 feet because they give you the diameter as 14. So I would say pi times 7 square over 3, because we divide by 3, times 18. So that would be 6 times 49, or 294 pi. But if you want it in like with 2 decimal places, or just, just let's round it as a like integer, I will get 924 cube feet. Notice when it's a volume, you have to write feet cube. Understand that like we multiply number, we also multiply units. And meaning the R here is in feet. R square would be in feet square. H is in feet. So when you multiply feet square by feet, you get feet cube. Like when you multiply 4 by 4, you get 4 square. When you multiply inch by inch, you get inch square. So always understand that for a surface area, the units will always be squared. For a volume, it will always be cube. And for a length, it's just a unit. Centimeter, kilometer, mile, decimeter, whatever, micron. Okay, here the volume is 4/3 pi r cubed. R is 6. 6 cubed is 216 divided by 3, that's 72. So it's 288 pi. But we have a calculator, so we say 4/3 pi times r, which is 9 cube. So you get, again, when you round it, you get 3054 cubic inch. Notice I told you what, 288? No, I said 72. That doesn't make sense. Oh, this is 9. Why did I say 9 cube is 729? So when you divide, this is 243. So 972 is 972. Why did I do math error? No, it's correct. I thought I messed it up. This is just a rectangular prism. Notice, I said I can look at this face and say it has an area of 50 square centimeter, and 50, 50, 50 for a distance of 2. So 50 times 2 is 100. Or someone else would say, no, I'm going to take this face. This is 2 by 5 or 10. But this 10 stays 10 for a distance of 10. So 10 times 10 is 100. Someone else would say, no, I'm going to take the top, which is 2 times 10, 20. And this 20 stayed 20 for a distance of 5. So 20 times 5 is 100. So no matter what you do, you will end up with 100 cubic centimeter. You don't need a calculator for that. You can say volume equals 5 times 10 times 2 equals 100 cubic centimeter. For a triangular prism, okay, I have a triangle. I can find its area. And since this area doesn't change for a distance of 20, I'm going to multiply the area by 20. So I'm going to say the volume equals 1/2 base times height of the triangle times the height of the prism. 20 over 2 is 10. This is 96, so 960 cubic centimeters. Again, you can say 1/2, 0.5, times 12 times 8 times 20 equals 960. Okay, this one is identical to that. We just put it upside down. And as I said, you can consider this face or that face or that face and multiply by the vertical height of that face. So for example, if I take this face, it's 6 times 8. And it stays 6 times 8 for a distance of 3 feet. So times 3. 6 times 8 is 48. And 48 times 3 is 144. 6 times 8 times 3 is 144 cubic feet. Here we have a cylinder. We didn't talk about the volume of the cylinder, but it's so easy. I look at the base. It has a radius of 4 millimeters, right? So I get the area of the base, and since this area doesn't change for a distance of 8, I'm going to multiply it by 8. So I'm going to say pi times r squared times 8. Pi r squared times the height. It doesn't change. This one changes, so I cannot apply the same logic, and that's why we divide by 3. And you would understand why we divide by 3, not by 2, like in areas, and probably you would learn that later. In fact, when you take calculus, there is a video I'm showing. It's called Papa's theorem, and Papa's theorem will give you the volume. If you know the area of the triangle, and you know something we call the centroid or the center of mass, you can easily find the volume. If you know any two of those, so if you know the area and the volume, you can find the center of mass. If you know the volume and the center of mass, you can find the area, which is ridiculous that you know the volume and not the area, but it's so easy. Anyway, so this is 16 times 8 is 128 pi. 128 pi equal this. Oh, but let's do it mathematically. Pi times 4 squared times 8. So if I did any error, so if we round it, you get 402 cubic millimeter. Of course, in your homework or test, they may ask you to use like a tenth, round it to a nearest tenth or hundredth or thousandths. Here, I'm assuming we are rounding it to the nearest integer unit. This one is half a sphere. We said the volume of a sphere is 4/3. So volume of a hemisphere would be half of that. Oops. Half of 4 is 2, so 2/3 pi r cubed. Right? So I'm going to say 2/3 pi, and r here is 15 cubed. 225, 11, well, what? 675, 1350 pi? Is it 1350 pi? I don't know how to do math. No, 1250, not 13. Why 13? This is 225 times 5, which is 1125, times 2 is... No. I messed it up. I messed it up badly. 2250. Oh my God. Is it? Let's see. 2/3. I don't know how to do math. I forgot. 15 cubed. No, still didn't lose that. 7,069 cubic inch. You have to write the units. And if they don't show you anything, you say cubic units. Okay? But don't leave it as a number because the number doesn't make any sense to me. If you don't tell me, are these centimeters or inches or yards or meters, how do I know that your answer is correct? Okay, this is with feet. So these three are identical. Again, you multiply the three dimensions. This is a rectangular prism, but the base is a square, 25. 25 times 10 is 250. So we say, again, we can either say this face has an area of 25 and that area didn't change for a distance of 10, so I'm going to multiply it by 10. Someone else can take the side or the top, they are identical, 10 by 5, 50, and they say, oh, that area didn't change for a length of 5, so I multiplied by 5. It doesn't matter. At the end of the day, it's 5 times 5, 25 times 10, 250 cubic feet. And finally, we have an identical cone. We say it's 1/3. Here, the radius already is 8. So pi times 8 square times 18. Okay? So 64 times 6 is 384 pi. I think so. Well, we can do it. Pi over 3 times 8 square times 18. Yeah, it is 1206 cubic meter. I hope this was clear to you. Of course, in a test, they give you a sheet with the formulas of, a volume of a cone or a pyramid or a sphere. I would rather have you not memorize these. In fact, maybe you need to memorize the cone, and a cone is the same as a pyramid, meaning 1/3 area of base times the height, and the sphere is 4/3 pi r cubed, but the rest are really easy. As I told you, you see that I have an area that doesn't change for a distance of 20. So I find the area and multiply it by 20. I have an area of a face or a side or a top, and this area doesn't change for a distance, then you find the area of any of these faces and multiply it by the perpendicular distance. If you have a cylinder, you find the area of the base, and that area doesn't change for a distance of 8, so you multiply it by the height, which is 8. Yes, I can memorize and say, oh, it's the area of the base times the height, so it's pi r square h. Why? There is nothing to memorize if the shape is uniform. What I mean by uniform is that the bottom is a circle. Oh, a circle with a diameter of 8 or a radius of 4. The top is identical. Any circle in the middle is identical. So all what you have to do is to find. So I want you to understand rather than memorize, if you can. Okay? Try to limit what you memorize and try to understand more. So you can easily, if you understand that if you have a shape, an area that doesn't change all the way till the end of the shape, then all what you have to do is to find the area of the base, which hopefully you know pi r square, and multiply it by the height. For this, for these 5 shapes, all what I had to do is to find the area of the base multiplied by the height. There is no reason to memorize anything. Yes, as I said, for the cone or the pyramid, which is identical, 1/3 area of base times height. The base may be a square or a rectangle or a triangle, but and the sphere. So, and then after a while, probably you would memorize them like I did, even though I learned that like in the last millennium, right? So you wouldn't forget them. Anyway, I hope this wasn't as bad as I thought, because in the beginning, I think we had a lot of stuff, because I forgot to tell you about the surface area of a sphere yesterday, which is 4 pi r squared. So that's an important one because it's hard to find it yourself with, because you also need higher level math to be able to prove that. But the rest are simple, okay? Um, and that's basically it. If you have any questions, please let me know by leaving me a comment in the comment section. Otherwise, I wish you all the best and hope to see you soon.